Yeah, I don't have eyes on, so I didn't want to dispute you, but I know it's right. All right, so anything else about grades or quiz or anything? Okay. Yeah. Yeah. I might not respond as quickly as normal. I will be in and out of town doing stuff, so, but I will still check my email. So, you know, and I normally get stuff graded before I try to do stuff for spring break, so I don't have it like hanging over me, you know. What's funny, real quick, as students, you want to be careful about doing that, because if you do everything at the beginning of spring break, it will leak out of your brain. And then you come back and then Monday's like, who are you again? What? So what you want to try to do is leave some stuff for that weekend right before you, just to kind of get your brain back into calculus gear, right? Okay. Anything else before we get back into firming up a few things? Okay. Very first thing I want to do, let's just kind of refresh what we did last time, and then I'll firm up a few things from earlier in the chapter. The last things we did were the alternating series test, right? And what does it take for the alternating series test to be met? I love it. Very first thing for you when he's alternating series test, it better be alternating. I love it. There's a problem. All right. So if it is alternating, if it's got that piece, now what's got to be, given that it's written like this, what's got to be true about this?
It's convergent.
All right, cool. I love it. So the limit, as n goes to infinity, of an must be what?
0.
0. So that has a chance to converge, which is sort of interpreted what you just said as that. You guys remember what's the other thing that's got to be true? It's a lot like integral test in this one.
Decreasing?
Yeah, this has got to be decreasing. So this has got to be less than this. And all of them have to be greater than 0. So the next term has to be less than the term before. It's got to be decreasing. One way you can show that is derivatives. Sometimes that's the best way. The other way to do it is to actually, so if I had this, this here, right? So you can show pretty quickly the limit is 0. You with me? In fact, what is the an that we're working with here? Yeah, you just ignore the negative 1 to the n part. So there's your heart of the elements. And the alternating series, the alternating part you just kind of put aside for a second. So I want to show that an plus 1 is less than an. Well, what is an plus 1? I love it. If an is 1 over n plus 1, what's an plus 1? I love you. What is a3? What? How'd you do that? How'd you do that? You just put a, what'd you put in? You just put a 3 in there, right? I love it. You're all looking like, dude, it's freaking a, and 1 over 4. What do you want? A3 says n is 3. So you just put a 3 in, right? So a3 is 1 over 3 plus 1 is 1 over 4. So what is a sub n plus 1? 1 over n plus 1 plus 1. Which is 1 over n plus 2. How does that compare to an? Which one's smaller?
Or an plus 1.
Yeah, this one's smaller because the bottom's bigger, right?
Yeah.
So that's all you got. You don't have to do derivatives. So sometimes it's quicker just to look at the n plus 1th term compared to the nth term. You just have to show that the next term is less than the one before it. And sometimes derivatives are easier. You just have to show that the derivative is negative, because then it'll be decreasing. Oh, for you guys, sorry. Okay. So that's alternating series test. And we also looked at absolute convergence. So if I wanted you to test test this, right, better, there you go. For absolute convergence. What does that mean, absolute convergence? It's one of the best things ever.
Converges no matter like what happens in a way, in a sense.
Yeah, but be very direct using a word from the thing I'm telling you. Absolute convergence.
And if A and it's absolute, it's still.
Yes, if you take the absolute value of this, what happens? Right? That's what absolute convergence means. It's almost too nice to believe. So let this make sense. If I leave an alternating part in, doesn't that make it easier for the series to converge? If every other term is negative, or let me say it more generally, if every other term is a different sign than the term before, would it be easier for that to converge? Because now it's not constantly adding to itself, and it's sort of taking away from itself on the way. Those should converge more, right? More of those should converge. So absolute convergence says, sort of like what you're saying, if you take the absolute value and it still converges, that's like a stronger convergence. Does that make sense? You don't let it subtract from itself, and it still converges, like, I've still got it. You're like, all right, you absolutely converge then. So if I say test for absolute convergence, I'm actually telling you what the shit to do. Take the absolute value. Now, does anyone see something about cosine n? What's weird about cosine n? Can anyone tell me anything that's weird about cosine n?
It's gonna be 1 over.
Say again?
It's gonna be 1, like between the.
Yes, sometimes it'll be positive, sometimes it'll be negative. Is it perfectly positive, negative, positive, negative? Nope. Sometimes it'll be positive, sometimes it'll be negative. So I really want this to make sense. I believe this is sort of like a homework problem, if I remember correctly. So I look at the absolute value of this. What is the absolute value of n squared? N squared, 5. Let me see if you guys get this. There is a test we recently learned that will make this crazy easy to investigate. In fact, somebody just told me what's true about cosine. In fact, what's true about an absolute value of cosine n? It goes from 1 to 0, or 0 to 1. What test would allow me to use the maximum value to say something about this? I really want you guys to get this. In fact, can you write it more specifically? The absolute value of cosine n, how do you tell me what you just told me? It goes from 0 to 1. Tell me mathematically. How can you write it?
0 greater than, or less than, and then less than.
What test does that remind you of? Direct comparison. It's got inequalities built into the shit. So there will be some problems with trig functions within yours, and just realize they are bounded. They are asking for direct comparison. They tell you what the shit to do with the inequality. So how can I rewrite? So if I look at this, by the way, the biggest cosine can be is 1. What do you guys think then about this cosine n over n squared? Do you think it's going to converge or diverge?
Converge.
Converge, right?
Mm-hmm.
So do I want to find a ceiling or a floor?
The ceiling.
I want to find a ceiling. So what is this less than or equal to?
1 over.
You just told me.
1 over n squared.
Yeah, what does this do?
Converge.
Because
P.
C series, p equal 2 greater than 1, convergent. Therefore, this one converges. So what does this do? Absolutely converges. Kick ass. All right, I love it. I love it. So when I ask you, does this absolutely converge? The very first thing you do is take an absolute value of the damn thing, right? Normally that means this part goes away. But there are some like this where it's not really alternating, but it is sometimes negative. And very often those are going to involve trig functions that have bounds. So any function that has bounds is just ready for inequalities. They come with inequalities. Right? It's less than or equal to 1. It already has that inherently. Okay, maybe. Maybe. So I want to show you that example. And it was kind of a nice, I wanted to show you that, and it kind of bled into a little review of what we did last time. And it led into a little review of direct comparison. Holy crap. Okay. That's one thing. So that's basically where we made it. And this test is just on the first, I don't know if you agree with the word just. It's just on the sections 11.1 to 11.5. And again, that'll be 2 weeks from today, the Wednesday after spring break. Okay, I like it. So, we finished that. We're right on track. I love it. We're right on track. So what I want to do now is just kind of like firm up a couple of things from earlier in this chapter. Some of them I didn't really directly talk about myself because Patrick talked about some of these things. So I kind of had a little series of things. Can you guys take a minute and figure out for me, first off, can we all agree that that converges?
Yes.
What kind of series is it?
Geometric.
Geometric, and when does it converge?
R is less than 1.
R is 3/5 less than 1. I love it, right? I love it, kick ass. So you pray for geometric series, right? Because you know a lot of shit. Can you just take a minute and tell me what it converges to? Figure it out, don't say anything. I want to know what that series converges to. So you got to remember the formula,
15 over.
which you needed for the quiz, so. What's the formula?
A over 1 minus
Over
R.
R minus
Yeah.
X.
What's R?
3/5.
3/5. And in this case also, what's A?
3/5.
Yeah, it's the first element, so when you plug a 1 in, you get 3/5.
So it's 15 over 10.
1 over
Wait,
5.
I check it.
So watch this. It's 3/5 over 2/5. The over 5 cancels, so it's 3/2.
Oh, same thing.
I like what you're doing. Multiply by 5, so it'll be 3 over 5 minus 3. 3 over 2. Bam. You can get it out. All right. Again, beautiful. You got to memorize that. Hopefully, you had to memorize, or else. Now, what I want to ask you is a couple things. One thing I want to ask you is, what the shit would this be then? You see how that's a different question, but it's not that different. Which one of these should be bigger? First one, because these are all positive terms, right? And this has more of them, doesn't it? Now, it's kind of weird that they both have an infinite number. But this one is not including the first term. That actually tells you how to figure this guy out. Don't we know what this one adds up to be? So it's not 3/2. How much off from 3/2 is it? The first term. It's missing the first term. So it's missing the n equals 1. So I just subtract 3/5. That would be 15 minus 6, 9 over 10, yeah. Ruko, right? What's 3 times 3?
9,
What's 2 times 5?
10.
I don't know.
Oh, it's 15 over 6.
There's something in there. When the tops are the same, there's something neat. I did it a while back. Anyway, I can't remember. So don't take anything of it. So that's 9/10, which is less than 3/2, because this is missing one term. So if I said n equals 4 to infinity, you would just figure out the first 3 terms and subtract what you get from 3/2. Does that make sense?
Yeah.
Okay. There's a few homework problems that are sort of related to that idea. And this is going to become big, coupled with something else I'm going to talk about in a minute. Something else I want to do with this. Can anyone tell me what this is?
Convergence.
Not if it converges or whatever. We actually know it converges.
The sum.
15
Oh,
over 2.
The sum formula?
Yeah. What's that?
3/2.
3 halves. So what's this?
15/5.
Yeah, 15.
Oh,
So it's 6 times 3 halves, correct?
Yeah.
You're hearing some weird, yeah, 9. So, everybody's saying 15, 9. It's not. All right. So again, any multiple of a series, if it converges, it'll just converge. If that series converges, it'll just converge to that multiple of it. If it diverges, it'll still diverge. 6 times infinity is still infinity, right? And by the way, before I make, I gotta be real careful how I say things. What does divergent mean? The series diverges. What does that mean? No, that's one way it could diverge.
It doesn't go to a single.
It doesn't go to a single value. Because otherwise you can have like oscillatory divergence, for example, right? Which is the most immediate other way to diverge. Right? It just doesn't agree on a single thing it's going to. It's just sort of like bouncing around some options. And so when you have cosine in there, it could do that. Why the one we just do? Why didn't it do that? Because it was divided by n squared. So it was getting smaller. So it was actually approaching the value. Okay. So that's one little piece. There's a little bit of algebra of these things. I want to do one more thing with this. So kind of keep track of this fact. How would you do this?
Turn it into harmonic. Or like get the 5. And so, like,
Okay, say that word you're about to say.
Like to separate them.
Yes, okay. So, isn't this equal to this? You see how those are the same thing? I like it, and I know this is going to date me, but when you do your checkbook, oh shit, don't you would add up all the negative shit and then add up all the positive shit and put them together at the end, right? It's a quick way to do your checkbook. Those are things that we used to. Sort of related to this. So that's and what are each of these? What type of series are each of these? So if they give you this and they say, what does this converge to? Break it up. They're each geometric. So then you can find what that, and when that's 3 halves, you can figure out what that is, right? Same way. And then just subtract the 2 numbers. It's a little bit more of algebra of the series. Good. Oh, let's see. Real quick thing in the homework. There's a really, really, really stupid cool thing in the homework. I think it's this, and they actually tell you. I can't remember. It's in 11.3, number 36. Right. This comes from Euler, and Euler did like way too much. He's the guy that actually came up with the number e, the exponential. He didn't call it e because his name starts with an e. He called it e because that was the letter he was on in terms of shit he was discovering. You understand? Well, this is this one, e. We'll call that e. So that's why we have e to the x now. Okay, so it's a little big, right? It's something that all math people is like, I want to discover something like e shit. All right. This is in a homework problem. They just tell it to you. Let me let you just look at that for a minute. That is a fact, by the way. That is true. Now, does anyone have thoughts on that besides, I wish you hadn't shown me that? Does this interest anybody? Does this surprise anybody? So really think about what this means, yes?
Why?
I love it, beautiful. So that's the very first thing. So I put up on Canvas the actual proof of this. And within the proof of this is something we're going to learn later in chapter 11. So it's a little preview of that. So you're going to see something written in the proof that you're going to be like, why is that true? We'll actually learn it. You'll actually be able to create that thing yourself. But I got the proof up there. It's really kind of cool. So there's a homework problem that tells you this, and then they ask you stuff like, well, then what's this? That's easy now, right? It's exactly like the one we did earlier. It's just, it's missing the first term. The first term is 1, so it's going to be that minus 1. Okay. So it doesn't do anything crazy with this. It's just that when you see this in the homework, I would hope somebody would go, why is that true? Or how does that work? Or, why the shit is it pi? And it's squared. What? So this is not obvious. So 1 plus 1/4 plus 1/9 somehow adds up to be this. That is funkadelic. Okay, sorry. I just wanted to point that out. And I put that up on Canvas if you want to take a look at the proof. And every step will make sense once we're done with chapter 11. But it's up there. Then I want to talk about this here. What if I said, I want to know what that is? I want to know exactly what that is. Right? And I want you to be honest. What would your first reaction to that question be? I love it. That's a good question. I love it. I want you to write it down like a cool. That's a good question. Maybe don't do it. Maybe actually do it. Yeah, that's a good question. So on first blush, when you first look at that, you're like, how the shit would I know, dude? Is it geometric?
No.
Hell no. That's all we really know, right? I mean, to figure out the actual sum of something, that's really it. But I could do, I'm not going to do all the steps, but I could do partial fractions, yes? And if you do partial fractions, you actually get this. On the first glance, this is going to be like, oh, okay, so what? Can you guys help me write out a few terms of this? That is actually a much more useful form for it. If you don't believe me, n plus 2 minus n is 2 over n times n plus o. Okay, so there you go. Give me the first term. The first couple pieces to it. When you n is 1, what do you get?
2 over 3.
Oh, I got you. So you get 1 minus 1/3, right? So don't put them together, trust me.
No.
So this is n equal 1. N equals 2, what do you get?
1/2 over minus 4, 1 over 4.
I love it. Keep going. I need more room. Go away, Euler. Freaking okay. Now, n equal 3.
1/3.
Got it. Now, n equal 4.
1/4.
Right? And do you already see something happening? Does anyone notice something happening? And this is why you don't want to combine them. You see how this piece cancels with that? This piece cancels with that. Will this ever cancel? You guys see how you can see now, you've written it up out, you can tell 1/2 is not going to cancel. It's never going to be 1/2 again. Will this cancel? Can you see that it's going to be the next?
Yeah.
Will this cancel? Can you see how it's going to be the next? Right? I'm sorry, where did I go? It's going to eventually be a 1/6 here, right? Now, this is not good enough. You have to go to the end. And so what I mean is, I want to know what the nth sum is. So let's go to the end. Let me I'm going to go to the end, and I'm going to write some stuff backwards. So what's the nth term look like? You already know, from the beginning you know what the nth term looks like.
1 over n.
Yeah, whatever n. This is the n term. What does the n minus 1th term look like?
1 over n minus 1.
Yeah, you just take 1 away from each of those, right?
Plus 1.
11. And what's the n minus 2th term?
1 over n minus 2. 1 over n.
Yeah. N minus 3, n minus 3rd terms look like. 1 over n minus 3. Where am I at? Minus 1 over n minus 1. Okay, that might be enough. So let's see. What do you notice happening? Doesn't the negative 1 over n cancel with that one? Doesn't the negative 1 over n minus 1 cancel with that one? Let's see. Okay, I like it. And do you see how the n minus 2 will have an n minus, is going to cancel also, and this is going to cancel? So what's left at the end? So Sn is 1 plus 1/2, minus 1 over n plus 1 minus 1 over n plus 2. That's the nth sum. So this is how telescoping series works. They don't start off necessarily looking like them. Telescoping looks like fraction minus fraction. Because then there's a possibility of this cross cancellation through the terms. Now, how do I figure out the actual full sum? Who remembers what we talked about earlier?
Take the limit.
Take the limit. We'll let n go to infinity. What happens if I let n go to infinity? What do these two do?
Zero. Zero.
So this sums up to be 3x. Crazy. So now telescoping series are the other kind of series that we can actually figure out what their sum is. Yeah, like it. Do you see how this hides the fact that it is internally subtracting? But whenever I like, oh, I'm like, oh, cool, it's got a chance. Some of it's subtracting from other bits of it. Maybe. Okay. So that does show up in the homework. Okay, that's that. Oh, okay, so very last thing, and this will be relatively quick, so we'll get out of here in a minute. Is everybody cool with that? You guys got that? I'm hopeful. Did you guys talk about that when I wasn't here? Telescoping? Yeah? Okay, all right. So you guys are like, dude, I don't know what I did yesterday. All right, I know that feeling. So the last thing I want to talk about, I talked about a little bit earlier, but if I had something like this, do you see how that, did you see what that's trying to be? What kind of series is that trying to be? P series. You guys, everybody see that? Here's the flexibility with series that we need to get used to. The way we define n is a little arbitrary, right? And I want to show you what I mean. So what would the first few terms of this be?
3 over 1.
Right?
3 over 4.
Yeah, this will be 6 minus 4, 2 squared, 3 over 2 squared, right? So forth. Okay, so watch this. What if I wanted to start at 1 instead, but I want this to represent the same terms? A series is equivalent to another series if they both produce the same terms. That kind of makes sense. So it's really, there's a billion ways I can write this series in this summation form. There's actually an infinite number of ways. So I'd much rather have it so that the bottom is n squared, right?
Yeah.
So what am I doing? I want to get you guys there. So I'm sorry, I gave it away. So if I want the bottom to be n squared, then therefore I want n to start at 1. And real quick, do you see how you made it start 4 earlier? Therefore this could move 4 over. It's like a shift. If your inputs get 4 smaller, this can get 4 bigger. And it will have the same results. And of course the top is still just 3. And now that's freaking, you don't have to do any direct comparison bullshit, right? You can take the 3 out, it's just a P series, converges linearly, right? Now I'm not saying you're gonna be able to do that frequently. What I am saying is this idea of adjusting, in fact, I don't think I've said this word yet. It's called the index. This idea of adjusting the index of the summation is going to become huge later. When we start trying to combine series, we need like terms and the like, so we want to get used to how to adjust these things. This is the first little baby step in that direction. So let me give you 2 things. One thing I want to give you is this crazy useful sheet. Now what's going to be a little weird is, this is actually related to section 11.7. 11.7 is sort of like that one section in chapter 7 where it gave you all the integration forms and you just had to do whatever the shit it was. Okay. So 11.7 has got all the summation stuff, right? So it's going to include root test and ratio test. These 2 at the bottom we haven't done yet. They're in 11.6. But everything above that is all the stuff we've already done. So I've got the idea, I've got sort of some backstory. So this is a good thing to have sitting next to you as you're doing homework, right? So let me give you this thing. And then the other thing is just the practice test. So One in there for you. Oh, man. It's way back there. You wanna go back there?
Sure.
Thanks, man.
Yeah.
Oh, right there. It's all right. Try to be nice and I confused everybody. That's why I'm normally not nice. It makes it easy. And then, as soon as you get the practice test, you can definitely head out, and I hope you have a good spring break. Sorry, I'm an evil person. You know this. Shit, did I have enough of these? I love it. Well, shit. I'll put it up on canvas, guys. I'm sorry. It must be stuck in the printer. I love it. Darn it. Let me see. Maybe it's stuck in my